This video gives an outline of how to find exponential Fourier series coefficients for x of t, and x of t is described over here. So initially we can find the time period, that is the time period after which the signal would repeat itself. So this is a periodic signal, so hence the time period t naught is from -1 until 2, so that is t naught is 3, and this would relate to angular frequency, that is omega naught, which is 2 pi by t naught, and hence this is 2 by 3 pi. Now regarding the DC value, that is the first coefficient a naught, so this is simply 1 over t naught and then the integration over the time period t naught x of t dt. So over here the time period is 3, so we will have 1 by 3, and we're going to integrate initially this part from -1 to 0, that is from -1 to 0, and in that part the value of the signal is 2, so we would have a 2 here, and then this is with the integration is with respect to the time t, plus again 1 by 3, that is the time period, and now we are going to consider this part which starts from 0 and then terminates at 1, and over here the magnitude is 1, so 1 dt, right? So this is going to be 1 by 3, and this is 2 plus 1 by 3, this would be 1, and hence overall we have simply a value of 1. So this is our a naught. Now let us move towards the coefficients when k is not equal to 0. So in that case again we have the analysis expression, which is 1 over t naught and then the integration with to t naught x of t e to the power minus j k omega naught t dt. We know that the time period is 3, so we got 1 by 3, and as done over here we're going to break the signal into two parts, the first one starting from -1 to 0, and in that case the magnitude is 2, which would be multiplied with the exponential, that is e to the power minus j k omega naught t dt, and again we would have 1 by 3 from 0 to 1 with the magnitude of 1 e to the power minus j k omega naught t dt. Now this would yield a solution, this integration would yield a solution which is 1 by 3 into minus 1 over j k omega naught. We would have this 2 as well, so we can take that out and we can have a 2 here. So we would be left with e to the power minus j k omega naught t with the value of t from the range -1 to 0. Similarly, on the right side we have 1 by 3 times the coefficients of the argument of the exponential from the integration. So we have -1 over j k omega naught, and then we have e to the power minus j k omega naught t, where t is now from 0 to 1. So we can take this jk omega naught common, so we would have 1 by 3 jk omega naught, and then there's a minus sign, so we will have a minus sign, and if we are going to put the value of 0 over here, so this would simply be exponential would be 1, and if we're going to put the value of -1 over here, so the value would be e to the power plus j k omega naught. And note that we also have this factor of 2 appearing over here, so we can write that 2 over here. So all of this has already been taken common, so we are left with a minus sign, from here, and then e to the power minus j k omega naught minus 1. So therefore our solution is 1 over 3 jk omega naught plus 2 e to the power jk omega naught minus e to the power minus jk omega naught, and then we have minus 2 and plus 1, so minus 1. Now this is the solution when k is not equal to 0. So afterwards we can simplify it further if we need, and we can express it in terms of uh, cos function plus j sine function for each of these exponentials, and then simplify, or we can write it in terms of sinc function. But usually over here this is sufficient expression.